Thank you for watching this video. So on this video we're doing question 8 of November 2022, question paper mathematics paper 2. The topic is circular geometry, as you can see here. So let's go. They are saying in the diagram, O is the center of the circle, MNPR is a cyclic quadrilateral, and SN is the diameter of the circle. They are saying chord MS and radius OR are drawn, and angle M2 is equal to 64 degrees. Okay. They're saying this diagram, O is the center of this circle here that you can see. They're saying MNPR is a cyclic quadrilateral, and SN is a diameter. So you know a diameter is a special chord that passes through the center of the circle. Right? Fine. They went on to say that MS and radius OR are drawn. So we have MS and radius OR that are drawn over there. They are saying angle M2 is equal to 64 degrees. That angle M2 is equal to 64 degrees. Fine. They are saying determine, giving reasons, the size of the following angles. So they want the sizes of the following angles, 8.1.1.1. On the first one, they want the size of angle P, right? They want the size of angle P. Where is angle P? Angle P is this angle here. So it is an angle in cyclic quadrilateral MNPR. So if you look at this cyclic quadrilateral, you see that angle P is an angle in this cyclic quadrilateral MNPR. So angle P is this angle here, and it falls on this cyclic quadrilateral. So how do we find that? If you watched my bed action lessons when I was doing geometry, I did explain that if you have a cyclic quadrilateral, the opposite angles of a cyclic quadrilateral are supplementary, which is they add up to 180 degrees. So if you add this angle and that angle, that should give you 180 degrees. If you add this entire angle and that entire angle over there, that should give you 180 degrees. So the opposite angle of a cyclic quadrilateral are supplementary. So in this case, we know that if we take our angle P and we add it with the opposite angle of the interior, if we take this angle P and add it with the opposite interior angle of the cyclic quadrilateral, which is M2, what we'll get 180 degrees. The reason we know that, the reason for this, we say these are opposite angles, right, of a cyclic quadrilateral, so of a cyclic quad. So we want angle P plus M2. We are given M2, that's equal to 64 degrees, is equal to 180 degrees. Therefore, solve your angle P, you get your angle P is equal to 116 degrees. So that's what you get. So let me also get my calculator. We get that 180 minus 64. Yes, it is 116 degrees. So this angle P here is 116 degrees. We're done with this one. So we move to 8.1.2. At 8.1.2, they want us to find angle M1. They want us to find angle M1. Where is angle M1? M1 is this angle over here. Fine. This, we have M1, we have M2. So how do we find M1? Look, where is M1 coming from? M1 is subtended by SR, right? SR subtend M1. This arc SR subtends M1, and this same arc subtends O1. But we don't have a lot of information about this. So how can you do this? Maybe what you can do, you can say the angle at the center, which is, if you look at this, O2 is subtended by NR, the entire arc NR, and O2 is subtended by NR. But look at this 64 here, which is M1, is also subtended by the same NR as well. So you can say angle at the center is double that at the circumference. So you can get O2. Once you know O2, you can find O1, because O1 plus O2, they give you 180 degrees. Once you have O1, you use the same thingy, same reason that angle center twice the angle circumference, then you can find that M1 over there. But also what you need to understand, you remember that they told us that, what did they say? They said that SN is a diameter. So we're told that Sn is a diameter. Where is Sn? Sn is this diameter here. So let me color it. We're told that this is a diameter. So what do you know about diameters? You know that diameters, they subtend right angles, right? Which is they subtend a 90-degree angle. So again, I covered this on my bad actions. You will find I did theorem 3 about diameters. So I was doing theorem 3, I did explain that if you have a diameter, the angle formed by a diameter will be 90 degrees all the time at the circumference of the circle. So in that case, if this is Sn, you know that entire angle over there is 90 degrees, right? So all angles subtended by a diameter are 90 degrees. So you know this entire angle here is 90 degrees, which is your M1 plus M2, they give you 90 degrees. So what you will say is, okay, my M1 plus my M2, they give you 90 degrees. Why? This angle in a semicircle or half a circle, which is an angle subtended by a diameter. The reason we say angle in semicircle, which is meaning that it's an angle subtended by a diameter, right? But we know what M2 is. M2 is 64. So in this case, we'll say, okay, M1, angle M1 plus 64 is equal to what? Is equal to 90 degrees, right? Therefore, your M1 is equal to 90 minus 64, which is about 26 degrees, right? But let me just double check. So 90 minus 64. Yes, it is 26 degrees. So we found that M1 is equal to 26 degrees. That's what I was trying to write 26 here. Fine. What else? At 8.1.3, they want us to find 8.1.3. They want us to find O1, angle O1. Where is angle O1? O1 is this angle over here. Where is this angle coming from? This angle is subtended by the arc, is formed by the arc SR, right? But this arc SR also forms M1. So that you know that the angle at the center, that's theorem 2 on my bad actions. Angle at the center is twice the angle at the circumference. So the angle at the center is double that at the circumference. So which means you will say, okay, O1, angle O1, which is this, will be double that at the circumference, equal to 2 times angle M1, right? And you say that angle at center, that's your reason, is equal to 2 times angle at circumference. So in that case, your O1, angle O1 is equal to 2 times angle M1, which is 26. So this should be about 51 degrees. So that is our angle O1. And that concludes our question 8.1. So what I'm going to do here, I'm going to clean the board and draw 8.2 diagrams, and then you answer 8.2. So let's go. Okay, so now we're done clearing the board, and now we're going to do 8.2. They are saying in the diagram, triangle ABG is drawn. D and E are midpoints of AB and AG respectively. AG and BG are produced to C and H respectively. F is a point on BC such that FG is parallel to CH. Okay, so let's go with this step by step. They're saying in the diagram, triangle ABG is drawn. So ABG, you can see it's a triangle over there. Fine. They went on to say D and E are midpoints of AB and AG respectively. So D and E are midpoints of AB and AG respectively. So D is a midpoint of AB and E is a midpoint of AG, as you can see over there. They are saying now, AG and BG are produced to C and H respectively. So, which is your AG is produced to C, and what else? And your BG your BG is reduced to H. So your AG is extended to C and your BG is extended to H, right? They're saying now F is a point on BC such that FG is parallel to CH. So there's a point F here such that your FG is parallel to CH, as you can see over there. Fine. At 8.1.1, they're saying give a reason why DE is parallel to BH. So they're telling you that DE is parallel to BH. So give a reason why. So they're saying DE, which is this length over here, is parallel to BH, which is this line over here. So they want you to give a reason for that. Fine. So they want us to tell why DE is parallel to GH, to BH, yes. So what you need to remember is the midpoint theorem, right? So I'm going to write it over here. Let's say midpoint theorem. So let's suppose that you have a triangle. I'm going to call it A, B, C, right? And let's suppose that there's a point D, which is the midpoint of AB. It's called D, and another point maybe E here, which is the midpoint of AC, which is the side is called this side. So let's join those 2 points, those 2 midpoints, right? So if you have a situation like this where there's a line segment joining midpoints of 2 sides of a triangle, right? That line segment will be parallel to the third side. And that line segment will be half the length of the third side. So you have a line segment DE, and it joins the midpoints of 2 sides of a triangle. So that line segment will be parallel to the third side, right? And also that line segment, its size will be half that of BC. So I'm saying that if your AD is equal to your DB, and your D and your AD is equal to DB, and your AE is equal to your EC, right? Then what will happen is, if this is true, then true implies, which is if you have this condition, this is what will happen. Your DE, which is this length over here, will be parallel to what? To BC. And the length of that DE of yours will be equal to your BC over 2, which will be half of BC. That is the midpoint theorem. So if you're looking here, if you're looking at this case, you have triangle ABG, right? And this line DE here is joining the midpoints of 2 sides of a triangle. So what will happen is that this DE of yours will be parallel to BG. And the length of this DE will be half that of BG. So now if your DE is parallel to BG, which means your DE is also parallel to BH, which is what they're saying. So the reason for this to be true, the reason for DE to be parallel to BH is because of the midpoint theorem. Because by midpoint theorem, your DE is parallel to BG, and BH is an extension of BG. Therefore, BH will also be parallel to DE. So the reason for this, it should be the midpoint theorem. Midpoint theorem. Because of the midpoint theorem, which is what I just explained over there. We're done with 8.2.1. Now we go to 8.2.2. So what are they saying at 8.2.2? They are saying now, it is further given that FC over BF is equal to 1 over 4. And DE is equal to 3x minus 1. And GH is equal to x plus 1. Calculate giving reason the value of x. So let me read this thing again. That's it. It is further given that FC over BH is equal to 1 over 4. Length DE is equal to 3x minus 1. And length GH is equal to x plus 1. Calculate giving reasons the value of x. So they want us to find the value of x. So what are we given? We're given that FC over BF is equal to what? 1 over 4. Where's FC? FC is this F. Where's F? FC is this length over here. We're told that this length over here, FC, the ratio of this length FC to BF which is to this length here, which is this length over this length. The ratio of this length FC over this length is called 1 over 4. Which is this length FC over this length BF is equal to 1 over 4. Does this mean FC is equal to 1? Not in general. Does this mean BF is equal to 4? Not in general. So what you see here is a simplified version of the ratio of, what you see, this 1 over 4 is a simplified, is the simplest answer of FC, the length of FC divided by that of BF. So what do we do? So in cases like this, here's what I always say. I want to think of FC. The length of AC would be 1 times A, and the length of FB is 4 times A. But you see, if you simplify, this will cancel out and becomes this. So this is the situation that has happened to get here, which means whatever this length was and whatever this length was, when you took the ratio of their lengths, it came down to this. So you can think of FC as 1 times A and BF, the length of BF as 4 times A. Of course, maybe your A is a positive real number, right? Which is this length of yours here. I'm going to write is the length of FC as 1A. So the length of FC is 1A. I'm not going to take it as 1 because it's not true in general. So I'm going to take as 1A here. The length of BF is going to be equal to 4A. So the entire length was 5A, whatever the value of A is. Fine. What else are we given? We're told that DE is equal to 3x minus 1. Where is DE? DE is this length over here. So we're told that it's 3x minus 1. It's going to be 3x minus 1. And then we're told that GH is equal to x plus 1. GH is this length over here. It's called x plus 1. So they want us to find what? The value of x. That's all we're given. Fine. So, they want us to find the value of x. So, when you're working with something like this, I think because if you look at triangle BHC, you can see BHC is also divided by this FG, and this FG is parallel to HC. So we can apply the proportionality theorem, right? So let's remind ourselves of the proportionality theorem. They are saying, if you have a situation like this on a proportionality theorem, you have triangle A, B, C, and there's a line. This is the proportionality theorem here. It's not midpoint. We're done with midpoint. So let's say there's D and there's E. So they're saying, a proportionality theorem, if you have triangle A, B, C, and you have a line segment joining two sides of your triangle, and that line segment joining two sides, which is DE, is parallel to the third side, which means this line will divide your sides of your triangle proportionally, which is at the same ratios. Let me try to repeat this thing again. They're saying if you're having triangle A, B, C, and you have a line segment DE that joins two sides of your triangle, such that that line segment is parallel to the third side, what will happen is that DE will divide both sides of your triangle proportionally, which is at the same ratios. In that case, which is your AD over DB, which is this side over this side, is equal to AE over EC. So what you need to understand, we're saying the top part over the bottom part is equal to the top part over the bottom part. It is not only that, that's not the only way in which proportions work, right? So as long as you're taking the ratios of the same parts, then those ratios will always be the same. For example, I said the top part over the bottom part is equal to the top part over the bottom part. I can say the bottom part, right, which is DB over the entire part, which is what? AB. It should be the same as the bottom part on the other side, which is the EC over the entire side, which is AC. So, as long as you take the ratios of the same parts, those ratios will always be the same. Right? That's what the proportionality theorem says. So if you're looking at triangle BHC, look at triangle BHC, this triangle over here. It's divided by FG, and the FG is parallel to the third side. So this FG of yours will be dividing these two sides at the same ratio, which is in the same way as that. So which means what we can say is that in triangle B, in triangle BHC and triangle BGF, what we can say, okay, our BG, which is this length over that length over GH, is equal to what? Is equal to BF over FC. So this is the proportionality theorem, right? Why is it working? It's working because we have two parallel lines, which is your FG is parallel to HC. That's why the proportionality theorem works. Because I said that if you have a triangle A, B, C, and you have a line segment dividing two sides of your triangle, so that line segment is parallel to the third side, then this line will be dividing both sides of the triangle at the same ratios. So that's what we're applying here, because we have triangle A, B, H, C, and it's divided by FG, and that FG is parallel to the third side. So if you take the ratios of the same parts, they should be the same, which is your BG over your GH should be the same as BF over the FC, right? No problem. But then now, what the value of X? If you look here, we don't have BG. GH, yes, we do, it's X plus 1. FB, yes, we do have something. FC, yes, we do have something. So we're only missing this. But we can find this using the midpoint theorem, right? Because we said that DE, which is this length, will be half that, right? Which is, this is double BE. So let's, in that case, if you apply this midpoint theorem, this length should be half this length. The length of DE should be BC over 2 is average in there. Which is, in this case, you apply the midpoint theorem, because the midpoint theorem applies on the top one, and then on this one you have a proportionality theorem, right? So these two things, of course, they look similar, because this one is a specialized version of this. So this is a special case for proportionality theorem. So you can think of a midpoint theorem as a proportionality theorem, but a specialized version, perfect conditions for it. That's what I mean by specialized version. So in that case, because of the midpoint theorem, we can say, okay, DE is equal to your BG divided by 2. This is the midpoint theorem, right? So what is your DE? Your DE is 3x minus 1. Your BG is what you're trying to find. So BG over 2, you cross multiply. You get that your BG is equal to 6x minus 2. So you get that your BG over here is equal to 6x minus 2. Right? No problem. So now we can apply the proportional theorem in order, because we have BG, we have BF, we have everything. So let's just go. So in that case, we say, okay, our BG, we're substituting here. Actually, let me rewrite it. We said BG over GH is equal to BF over FC. Let me just double check. Say BG over GH is equal to BF over FC. So that is a proportionality theorem. I'm not going to write the reason because I've already written it there, right? So what I'm going to do, I'm just going to substitute. Your BG is 6x minus 2, right? Over GH, which is x plus 1, is equal to BF. Your BF is 4a over FC, which is 1a, right? Fine. So as I said, a's will go away. So what are we left with? We're left with 6x minus 2 over x plus 1 is equal to 4. Then you cross multiply, this is over 1. This time that is going to be 6x minus 2 is equal to 4x plus 4. Right? Then let's take this to this side and take this to that side. So we have 6x minus 4x is equal to 4 plus 2. So your 2x is equal to 6 divided by 2 divided by 2. Therefore, x is equal to 3, which is the value of x is equal to 3. So this is how I would have done this question. And I'm done with this question, and I hope this was familiar and you understood it. And if you don't, you can go to my back actions. You might get midpoint theorem, at least for now. I haven't recorded proportionality theorem as of this moment. And I hope this does make sense to you as it does to me. Thank you for watching. Let's go to question number 9. Cheers.